Okay, we're going to look at what urea, covalent molecular compound, doesn't dissociate. It dissolves, but it's not going to split up into ions. Now that means that, let me explain to this class, you've seen this other classes. If I had, let's take magnesium chloride, okay? Magnesium chloride, okay? If I split 1 mole, I put 1 mole of magnesium chloride into water. It's all going to completely ionize. It's a chlorine salt, light metal. It's going to dissociate. And I get plus what? Plus what? Come on, guys. I know it's early in the morning. It's 8:10 here in Abu Dhabi. It's cloudy skies. And it may rain meatballs later today, which is kind of what the car looks like after rain in Abu Dhabi. It looked like it rained meatballs. Antoine is like shaking his head, yeah, absolutely. And it's not just a shaking the head, it's a very cool shaking of the head, you know what I mean? He's going like this. This is, all right, this is Antoine agreeing. You ready? You ready? All right, ready, okay. Very subtle, I like that, I like that. Very, very cool agreement. Okay, so, and what else is it? What else? Cl minus 1, right? Like that? Is that balanced? It is? You got to balance it, right? So I have 1 mole of this. How many moles of ions am I going to have? 3 moles of ions. So it's going to have 3 times the effect, right? Yes or no? Yes. Yeah. So that N is 3. Right? Because if I calculate the molality of that solution in terms of ions, it's going to have 3 times the molality, isn't it? Yes. Right? Yes or no? Yes. So you got to put that N in. N is the number of particles after it dissociates or doesn't dissociate. So urea is a covalent substance. It's not going to dissociate. So I put 1 mole of urea here, I get 1 mole of urea dissolved. So N is 1. I put one mole of magnesium chloride here, I get 3 here. How about if I have something, this is probably a pretend example, but we'll do it. How about if I have this? Aluminum pyrophosphate. How many moles of aluminum ion am I going to have? How many? 4, exactly. 4. And how many moles of pyrophosphate am I going to have? I'm going to have 3. So how many moles of ions am I going to have relative to everything that's going on here? How many? 7. I'm going to have 7. So if I have 1 mole of this, I'm going to have 7 moles of this. So what would N be? What would N be if, what would N be? 7. N would be 7, right? You get it? So that's why they say in the problem, let me read the problem. It says, calculate the freezing point and boiling point of a solution that contains 15 grams of urea in 250 grams of water. Urea is a covalently bonded compound. You get it? Now, the general formula for this is going to be change in temperature equals NKM. So that's going to be, this is going to be for the freezing point, and I'll add that to the freezing point of water. or subtracted from the freezing point of water because it's a depression. And then this is going to be for the boiling point elevation. You get it? Yes? So this answer is going to be 1, freezing point is 1.86, and then it's 250 grams of urea? Is that correct, or 250 grams of water? What's the problem? 250 grams of water, right? So 0.250 kilograms, right? Because it's per kilogram, right? What's the urea? The compound is CH4N2O. CH4N2O. Is that correct?
Yes.
Okay. So that's going to be 16. That's going to be 28. And that's going to be 16. Correct? Is that right?
Yes.
Am I right or not?
Yes.
Help me out here, guys. Don't let me make a mistake. Okay? Did you hear my phone go off in the middle of this?
Yes.
Okay. Try to put it on stop, you know. So that's 32 plus 28 is 60. Do you read that right?
Yes.
Is that 60? Yes or no? Red, how you doing over there? Okay. So that's 60. All right. So that's going to be 60. Sorry. Yeah, that's going to be, what's the amount of urea? 15. So that's good. 15 over 60. Okay. 15 over 60 is what? 0.25, right? Yes or no?
Yes.
0.25 over 0.25 is what?
1.
1. Right? And then this is going to be, N is 1. This is 0.52. Right? I'm leaving off the unit labels because they're cool. That's the KB, KF. Right? And that's, we know that's moles because it's going to be grams over gram molecular weight, right?
Yes.
And then that's going to be
The total.
the liters, right? Yes or no?
Yes.
Okay, good. So I multiply this by 1 because I know this is 1, right? Because that's 0.25 over 0.25. Yes?
Yes.
Yes or no?
Yes.
Don't let me do this if you don't get it.
You're doing one.
Okay, you okay?
Yep.
Okay, so this is going to be 1.86, and this is going to be 0.52. In terms of the depression and the elevation, are you there?
Yes.
Yes or no?
Yes.
Tell me now, and don't lie. Are we all right? Gabby, are you speaking for the class? Are you the spokesperson for the class?
Yes.
You learned how to be a leader in Nepal, didn't you? And you are a spokesperson for the class, aren't you? Excellent, excellent. Thank you, Gabby. Extra credit. Okay, now. So the freezing point depression is going to be negative. So, sorry, it's going to be 1.86, but the freezing point of water of this solution is going to be just the temperature is going to equal what? Negative 1.86. Correct? Yes or no?
Yep.
Because we know that's going to be the depression, and that's the elevation. So the answer here, is this coming up on it? This is going to be what? 100.52, right? Yes or no?
Yes.
Don't lie.
Yes.
Yes or no?
Yes.
Yes or no?
Yes.
Excellent. Right? Easy?
Temperature.
Are we okay?
Yes. Wait, can you write down the problem number on the problem?
What was it, 82?
Yeah. So.
Okay. You get it? You all right? We'll do one more and then we'll go to the planetarium. Okay.